What is space? Usually it is understood as being something empty, in that when it is not empty, it is something that is three-dimensional, meaning it has three directions. Is this really true? If not, then what is space and what is its relationship to objects? The concept of three dimensions is not a deconstruction of spatial dimension, but it is a construction. The first dimension of space, as a linear direction or line segment, is just an example of one of the possible directions. Therefore, any direction that would precede the construction of all three dimensions. To understand this, a second linear extension of one-dimensional direction does not create a two-dimensional plane. What makes a two-dimensional plane is the relationship between the two linear directions, or the two line segments, assuming that there is at least some deviation in direction from the two lines. And so the relation between the two one-dimensional linear directions creates a unity of them both, thus creating a two-dimensional plane. If a third direction is introduced, and as long as there is, again, also some deviation in angle from the previously created plane as a whole, then a third new direction is added in unifying all three linear directions into one qualitative plane, the third dimension. This is a construction of addition of the spatial deviations. Why are there then only three-dimensional spaces? Not counting time, of course, let's say as the fourth dimension, nor things like probability. Most things, if not all, when given logical form and relations, come in a triadic form. That means it comes in three parts. The simplest example of this is basically any two objects and their relation to one another. Or if we do take a single object, it has a relationship to its parts. So the parts are relating to the object as a whole. The dimension of space is therefore not inherently three-dimensional, but rather is dividable into three as any object is, or possible dividable into even more spatial dimensions if we use different logic. Each added dimension or direction would give a new unity of set of dimensions unified. So, the inherent pre-divided spatial dimensions is therefore either zero or positively infinite, depending whether to give space a positive value or a negative value. Zero in the sense that space does not have any inherent dimension at all, and infinite in a positive way, in that it has all possible directions all at once already existing within it. This positively infinite value can also be represented as a value of 1 instead of 0, in a sense that it is an absolute singularity, expanded and instantiated to infinity. The positive infinity can also be said to simply be positive space instead of empty space, hence space as 1 or as 0 have the same definition when extrapolated to infinity, that is, that they are both absolutely homogeneous, whether it is 1 or 0. No other number has this definition of absolute homogeneity when extrapolated to infinity. For instance, 2 or 3 would have to have spaces in between, but 1 and 0 do not. So if the dimensionality of space is to be understood, the process by which the three dimensions relate to each other will help. What is space? Before considering the three dimensions. Before considering an object in space that would have these three dimensions. As stated before, it is either positive space as a value of absolute 1, or negative space as a value of absolute 0. The value of 0 is as empty space, and is infinite in an absolutely homogeneous state. It is empty everywhere, so to speak. The value of 1 is also as absolute space, and it is also infinite as an absolutely homogeneous state. and so it is full everywhere of one thing. The definition of space as something entirely empty does not offer any interaction with this emptiness unless an object is induced into this thought experiment of a definition. However, if the definition of space is as something full or fully present, then there is already something to work with to begin understanding potential structure. In either case, whether the value is 0 or 1, an induction is indeed made, but the difference is that in the case of the value being 0 for space, that's the end of the story. An object would be introduced in this empty space, and that's it. There is no possible relation between the object and empty space. There is an absolute division between the two. In the case of space having a positive value of 1, however, there is an already inherent value in the space. That is a positive value from which to work with. For example, to understand this value and potential structure, the potential value of 1 means that there is something already fully present throughout the infinity of space. So, how to find out this something without concocting an irrelevant induction? How do we go from induction to deduction in this particular case? Well, can we deduce from this positively infinite space? Well, we can call it an infinite in deduction, but the actual proper definition of space is absolute in that it is just one. For instance, the absolute, the sole part, is Latin meaning one. It is just one thing throughout. With this in mind, we need to create a division that would be inherently within it. The only thing that comes to mind as to what could constitute an absolute homogeneity would be an infinite amount of infinitely small particles. That is, the infinitely small particles are not taking up any dimensional space, therefore there is no division between the parts, no space, no empty space, and do not create a separation between their parts, thus maintaining the quality of the absolute, the quality of one. This is a game of abstraction, and the rules should be consistent and coherent. Therefore, to repeat the definition of an absolute infinity of space as a homogeneous singularity is maintained when dividing it into infinite parts of infinitely small pieces, which are infinite also within themselves, maintaining that homogeneity. So, what is something that is infinitely small? Do we have a reference point for this? Well, yes, we do, in fact. And the word has just been mentioned, a point in space as a location on a grid. It is infinitely small. A point is just a location of two or more things crossing, such as two lines crossing each other. In the case of infinite space with an infinite amount of points, well, what would this mean? Well, it means that infinity is crossing itself infinitely throughout infinity. Just like the lines, we could imagine two infinities crossing each other infinitely. This would create an infinite amount of points of infinity crossing itself infinitely. So, what can we do with this induction and deduction? Well, as a removed observer, we can choose one single point out of them all and see what happens. If a single point is to be focused on by an outside observer, then that point would create a specific relationship to the rest of infinity. That is, a relationship with its outer space, its outer infinity. This would then be a point of differentiation as an emerging property from the rest of all other points, if it is focused upon. All other points would then, from the point of view of that chosen point, just be space. By maintaining the definition we have so far, we have thus a single point by which all of infinity is relating to it. So all of infinity at large is relating to this one infinitesimal point. So this point becomes the center of infinity because all other points are being ignored from the perspective of the observer. Another emerging property that is happening is that there are two directions that emerge as a whole. the infinity at large that is funneling itself through that one single point, again from the point of view of the observer, and the second direction is the infinitely small point is introverted within itself infinitely. Thus, we now have a differentiation between two infinities, both of which are part of each other and are one and the same at the same time. And this is done, again, because of the observer. So, a question arises then. Is it possible to have a differentiation point within infinity without the observer? Well, yes. We assume that it can. We would just have to basically recreate the same conditions, but infinitely far removed from the first infinity. And so, from the perspective of the second infinity, the infinitely large, that first infinity will appear as an infinitely small point relative to the second infinity, and vice versa as well.